All right, everybody, welcome back. We are now in part 2 of chapter 12, non-renewable energy resources. And today we're going to talk about electricity and how electricity is generated. Our objective, I forgot to put it down here at the bottom, but our objective for this unit is to be able to compare the energy efficiencies of the extraction and conversion of different fuels. So if we take a look, first of all, at in terms of talking about electricity, we've got to talk about our primary and secondary sources. Our primary sources of energy, those are going to be coal, oil, the sun, etc. So that's where our energy starts. The electricity is going to be a secondary source of energy, okay? And it's an energy carrier, which is something that can move and deliver energy in a convenient, usable form. And that's the electricity. And for 40% of the energy that's used in the United States is electricity. But of that 40% that is used for electricity, 13% of that is unusable. 13% is available to use for actual purposes like appliances and light bulbs and things like that. The rest is lost due to heat. So again, only 13% is actually usable. These are the steps that are required to produce electricity from fossil fuels. Again, we're referring back to the law of thermodynamics, where we have energy transformations, and that's what's happening here. We're converting our original fuel into electricity. And you'll probably remember this. Again, this goes back to general science freshman year. First step is when we take our fuel, and that can be either our fossil fuel, or it could also be uranium too. But our fuel is burned, and that heat that's produced is going to be transferred to water, and that water will make steam. And that steam is going to have kinetic energy, and that kinetic energy and the steam is going to be transferred to the blades of a turbine. And a turbine, think of it as a very, very large fan. And so the steam is going to spin the fans of the turbine, and as the turbine spins, the shaft that's in the center is going to be connected to a generator. And the mechanical motion of the spinning shaft is going to generate the electricity. So again, those are the steps that are listed there for you, and this picture pretty much goes through the same thing that I just described. Again, we've got our fossil fuel coming in, and our boiler here. This is where the fossil fuel is going to be burned, and a byproduct, of course, is our ash down here. This boiling process, this burning process makes steam, and that steam is pressured, funneled through under high pressure to the turbine, and this turbine here is where the steam is going to spin those blades, and this center shaft right here, that's what's connected to the generator, and this generator is going to make the electricity. You can see the picture above up here of the generator and live in person, and then that electricity is then transferred to the transmissions lines, and then out onto the electrical grid. Now the water that, if we go back over here to the water, the steam over here that was used to spin the turbine, that steam is going to be condensed back into liquid water. And sometimes that water will be reused. It'll be sent back this way, and it'll be sent back to the boiler where it will be evaporated into steam again. Or also, sometimes that water is expelled to a nearby body of water. Okay, so it depends on the specific power plant with that. In terms of energy efficiency, most coal burning power plants are only about 35% efficient. So if we start with 100% of our energy in our coal that we start with, only 35% of that energy is going to be converted into usable electricity. The rest is lost as heat, or as the CO2, as the burned byproduct. We can see here that this graph shows us, if we take a look, the fuels that are used for electricity generation in the United States. Almost half are coal power plants. There's also natural gas, a little bit of oil, but also nuclear. And nuclear power plants, they work in the same fashion if we go back to our previous slide here, instead of the uranium being burned, the way nuclear power plants work is that you start with a radioactive isotope of uranium, and you take a neutron and you aim that neutron at the isotope, and that sets in a chain reaction into place. And so that'll create a new radioactive byproduct and more neutrons. And so that's how the chain reaction starts. And as part of that chain reaction, that's heat is produced. That's where the heat comes from. And so that heat is used to turn the water into steam, and then the rest of the process is the same. And so we can see that only about 11% of our electricity comes from renewable energy sources here. Now, I also want to mention something called combined cycle natural gas. This is if you've got a natural gas electricity power plant. This has 2 turbines and 2 generators. So the first thing that can happen is that if we're burning natural gas, the byproducts of that natural gas combustion reaction, those byproducts can be used to turn one turbine, which is connected to one generator, to make electricity. And then we can also have another turbine and another generator, and what can happen is that as part of that combustion of the natural gas, heat is also produced, which is separate from the regular byproducts. And so that heat can be used to boil water to make steam to turn the turbine. And so again, that is a little bit more efficient. That's 60% efficient. And so some power plants are built like that. I want to mention something called capacity as well. The capacity is the maximum electrical output of a power plant. Excuse me. So, for example, when a power plant is operating, it has a maximum capacity. That's the amount of power or electricity that can be produced. And so, and in the book it talks about a capacity of 500 megawatts. So what that means is if the plant operated for 1 hour, it would make 500 megawatts. If it operated for 24 hours, it would make 12,000 megawatt hours. Okay, and so that's capacity. There's also something called a capacity factor, and that's the fraction of the time that a power plant is operating. Okay, so some power plants are operated every single day. Some are not operated every single day. Most thermal power plants have a capacity of 0.9 or greater, but a lot of renewable energy power plants have capacity factors of only about 0.25%, and that could be could be wind, could be solar, and that again has to do with the amount of if you're talking about wind, the wind turbines are only going to be able to spin if it's windy. So that's only a fraction of the time. Solar power plants are only going to be able to produce electricity when it's sunny. Again, a fraction of the time. So that's a capacity factor. There's also something called a cogeneration power plant. And a cogeneration power plant is when a fuel is used to generate electricity as well as to produce heat. Okay, and as an example, if steam is used for industrial purposes, it could also be, or heat, it could also be used to turn a turbine first. And that can improve efficiency to as high as 90%. So again, cogeneration is when we use the fuel to generate electricity as well as produce heat. And that pretty much wraps up this section. Pretty short today. We've got our 3 checkpoint questions here. What is the basic process by which the energy in a fossil fuel is converted to electricity? What are the major fuels that are used to generate electricity in the U.S.? And what is a combined cycle plant, and what is a cogeneration power plant? Can go ahead and answer these in Edmodo. Don't forget, once you open up the questions in Edmodo, you are on a time crunch. So answer the questions right now. Get yourself all set up, and then log into Edmodo, and you can answer these. When you're done with that, that's the end of part 2, and we can move on to part 3.